Hey guys, welcome to your Unit 2 Lesson 2 notes on counting outcomes. Today I'm just going to give you a shortcut to how to count fast. But before I do, let's review some multiplication and some division rules. Go ahead and pause the video and try these examples. Okay, for our first one, we have a negative times a negative, so that's going to be a positive. We have 5.1 times 3, so we multiply 3 times 1, which is 3, and then 5 times 3, which is 15. Now up here we have one number behind our decimal point, so we need one number behind our decimal point. So our final answer is 15.3. Let's go on to number B. Yes, number B. Here we're going to combine like terms. We can combine the 2 and the 10. This is the same thing as 2 times 10. Nope. 2 times 10 times k. That 2 times 10 is 20. And 20 times k is as simple as it gets. So that's 20k. Next one, we have one negative sign. And we're going to rearrange all of our terms. This is the same thing as 3 times 9. I'm going to combine the numbers first, and then I'm going to put my variables in alphabetical order. Times B times C times F. Now because 3 and 9 are both numbers, I can combine them. That's 27 B, C, F. And make it negative because we had one negative in the original problem. Oh, here it goes. Okay. Multiplying by a -1 is the same thing as just having a negative number, negative sign in front of it. So that's the same thing as negative RS. And finally, 3/16 we can't simplify because there's nothing in common between 3 and 16. So that's the same thing. Okay, now that we have a nice multiplication review, let's get into our main lesson of the day, which is the fundamental counting principle. By the end of the day, you will be able to use the fundamental counting principle to count outcomes. I'm going to use a tree diagram to show you why it works, and then I'll tell you what the principle is. So first, let's do this the long way. Let's say that the sophomore class council is selling you ice cream, and these are your options. You first have vanilla, and then with your vanilla ice cream, you can either have chocolate or caramel. So you split it up like this, chocolate or caramel syrup. And then in addition to that, you can either have whipped cream or no whipped cream. So you can bring that down there and copy it down there. Oh, I need to spread these out a lot, don't I? Okay, so maybe I should put this like halfway between there. Right? So this already represents several options. You can either get vanilla ice cream with chocolate and whipped cream. You can get vanilla ice cream with chocolate syrup and no whipped cream, which would be my personal choice. You can get vanilla ice cream with caramel and whipped cream, or you can get vanilla with caramel and no whipped cream. However, that only represents 1/3 of our options. We haven't even begun to count the chocolate and the strawberry options yet. So we're going to take that same principle, we're going to copy it 3 times. This is your shortcut. Okay. But instead of getting vanilla, this will be chocolate ice cream. And so the same options still apply. You can get chocolate ice cream with chocolate syrup and yes, whipped cream. That might be a sugar overdose though. You could also do chocolate, no whipped cream, chocolate caramel, yes whipped cream, etc. And then finally, instead of getting vanilla ice cream or chocolate ice cream, you can get strawberry ice cream. I'm going to organize these as all being our strawberry color. Now let's count how many total items we have. The way to count the total, we call each of these items, we call them outcomes, because it's the way that they come out of the situation. Okay, let's count how many outcomes we have. The best way to count outcomes is just to go to your last column. We have this option, this option, this option. count how many we have. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. So there are 12 possible ice cream combinations that can be made. Super. Now, I'm going to show you a faster way. Actually, no, I'm not yet. Spoiler alert. So a tree diagram, this thing right here, because it looks kind of like a tree, especially if you rotate it 90 degrees. Got little trunks and branches and even more branches like that. Kind of looks like a tree. So this is called a tree diagram. Okay, so a tree diagram shows the different possible combinations of anything. In this case, it was ice cream. These results, as we said earlier, these are called outcomes. So the list of all possible outcomes we call the sample space. It's the space where you put all of your samples. Okay, so let's say that in the dance class, the dance department has 2 lead female dancers, which are named Emily and Olivia, and they also have 3 lead male dancers, Giovanni, Bradley, and Logan. How many different ways can the director choose a female and a male dancer to lead the next production? So what we need to do is we need to draw a tree diagram to find the total possible number of outcomes. Okay, first, and we'll start with Emily. Okay, and then it could be Emily and Giovanni, Emily and Bradley, or Emily and Logan. Those are our options. We don't have to have Emily, though. It could be Olivia. So maybe our female lead is Olivia. And we have Olivia and Giovanni, Olivia and Bradley, and Olivia and Logan. So that's our sample space. And this represents the options that I just said, which would be Emily and Giovanni, Emily and Bradley, Emily and Logan, or Olivia and Gio, Olivia and Brad, Olivia and Logan. So how many total number of outcomes do we have? We have 6 outcomes. So there are 6 different ways that we can pair up our leads. Now those 6 different ways we call outcomes, and if you take one of those choices, like one of these choices, we call those events. So the events we've seen today are like the choice, I'm not even going to write that out, the choice of female lead, or the choice of male lead, or the choice of chocolate syrup, etc. Those are all different events. So the event is like this kind of thing and this kind of thing. Those are each of the events. So how do the events relate to the number of outcomes? Well, let's look at our most recent dance example. How many choices of female dancers did we have? We had 2. How many choices of male dancers did we have? There were 3. How many possible outcomes did we have? We had 6 total outcomes. So how do these numbers relate to each other? Can you put them all in one equation? It should be 2 times 3 equals 6. And you guys, here is where the shortcut comes. This shortcut is called the fundamental counting principle. And it says, if an event, like style, can occur in m ways, like 3 ways, and is followed by an event, n, that can occur in n ways, then m followed by n can occur in m times n ways. So now let's say that we want to make some Algebra 1b t-shirts, and we want to figure out how many different possible combinations are present. We could totally go through and make our little tree diagram, but you guys, look at how many things we have. That's going to take so much time. So instead, let's use the fundamental counting principle to speed this up. How many choices of style? Let's look at we have 3 events: style, color, and size. For our first event is style. How many choices do we have here? 3. We have 3 styles. How many color choices do we have? We have 2. We have 2 colors. How many sizes do we have? We have 5. You guys, that would be such a big tree. Let's not do that. Okay, and the fundamental counting principle says that in order to find our total, we do m times n. So we're going to multiply all 3 of these across. 3 times 2 times 5 is, 3 times 2 is 6, and 6 times 5 is 30. Ta-da! Or guys, the even faster way to do it, 2 times 5 is 10, and 3 times 10 is 30. So that's super fun. Guys, that was it. That's the fundamental counting principle. Let's see if it worked on our first one. How many choices did we have of ice cream? We had 3 choices of this event. What about our topping event? Well, that had 2. And of our whipped cream event, that was 2. And 3 times 2 times 2 is 12. Hey, we had 12 outcomes. We did it right. Good job. I hope you have a fantastic time on your homework.